So hey guys, I'm back with a new video. In this video, let us learn about the Merkle root. So Merkle root is also one of the components that is the part of the block header. So this is right here, the Merkle root. So it is the hash that represents the entire transactions that happen inside the block, right? So let us continue with our slides. So to get the Merkle root, a pair of transactions that happen or that are placed within the block are repeatedly hashed together. So say this transaction and this transaction are taken and they are repeatedly hashed together. So each pair resolves into a single hash. So this pair resolves into this hash. This pair resolves into this hash. Then these two are taken in a pair and again they are repeatedly hashed, which gives us this. So the hash of the two pair of transactions that we took in the first place are hashed together, and then this happens over and over again until you are left with a single hash value. So given the final hash value, which is this one, this is known as the Merkle root. So we can also reverse the hashing to reconstruct the entire set of transactions from the original block. So now let us move forward to the concept of nonce. Now nonce has more to do with some topics that we will cover later, known as mining. So nonce is an arbitrary number that can only be used once when creating a hash for a block. Not just any value will work. The system requires a very specific hash value that starts with a certain number of zeros. Now these extra constraints make the hash even more difficult to find. To find that value, you combine all the block data with this nonce to try to generate the correct hash value. So computer guesses this nonce over and over again until finally they come up with a hash value that meets all the constraints. So the number of zeros that are requested to solve this problem is known as the block difficulty. If more zeros are needed, that is a more specific request. So it's a more difficult to find. If we ask for more zeros, the block difficulty will go up, and if the less zeros, then the block difficulty will go down. And we will cover about nonce in much more detail in a later part of this course. Now another attribute the block has is the block size. So a block size is the amount of space a block has to hold the information. Like your computer, there are certain limits to the amount of space on your block. So this amount of space inside the block is decided by the developer, and it helps control things like how long it takes for a block to fill up or how many blocks will be present in the blockchain. So once we have fixed the definition, we stick to that, and that will be same for every block in the blockchain, and it can only be changed by making updates to the software. So if the block size decided was say 2 MB, that means once the limit for the block is reached, the block is full and it's time to start generating a new one. Now another piece of information that you find in the block is the hash value, and more on hash value we discussed in a previous video of the course. So the link for the same can be found down below in the description section of this video. So finally, let us talk about the component, which is the blockchain itself. So getting every information onto the blockchain is the goal of the entire system, but it's helpful to understand it as a single component of this large system. So blockchain is a shared digital immutable ledger that contains the entire history of transactions that are made over the network. So it's an accumulation of these linked blocks that are joined together by the hash values that have been created over time. So all the information on the blockchain is permanent and cannot be tampered. This means that data on the blockchain is immutable and is tamper proof. So when using a blockchain, you have a permanent, unchanged history of information, which is useful for many different applications that are made over the blockchains. Now to construct the blockchain, you need two main things: the blocks and the hash values. Now as we know, every block contains its own hash value and the hash of the previous block in the blockchain. So these hash values chain the blockchain together in order in which the most recent block made all the way, which is this one for this diagram, to the very first block ever created. So the fact that these blocks are connected by hash values gives them some pretty interesting qualities. We know that if we change the data on a block, it will create a new hash value for that very block. So for example, if we change the current hash for block 0, the hash of the previous block for the block 1 will also get changed, because the hash of the previous block, this field itself points to the current hash of the block 0, right? So if we change the date on a block, it will create a new hash value for that block that will invalidate the block, and we will know it has been changed. Now what happens when we look at that block as a part of the blockchain? Now since the hash of the block changes, it also changes the hash of the block that exists on the next block. So this changes the data in that block as well, changing the hash value, and hence this block will also get invalidated. This change of hash values will run all the way down to the set of the blocks, effectively breaking the entire blockchain. Now you can identify any block by where it is located over the blockchain using its block number. So the block number is just a number telling where on the blockchain that block falls. So the second block in this chain is numbered as block 1. The first block in the blockchain is numbered as block 0, and the third block in the blockchain is numbered as block 2. The nth block is numbered as block n-1. Next, the first block on the blockchain also goes by other name called as Genesis block. So blockchain is just a single component in all of that where the transaction history is eventually stored. So this was all I wanted to cover in this video. In the next video, we will learn about the different blockchain networks. So let's catch up in the next one.